Ladies and gentlemen, welcome back to the True Life Podcast. We've got a quick intro video for you today. We're live all the way from Ben-Gurion University with an incredible individual, Professor Abraham Zangen, who is, if you have read a little bit about neuroplasticity, if you have read a little bit about using magnetics to change the way people interact with different disorders, then you've probably read about him. Doctor, I wanted just to give you a quick intro to introduce people to who you are and what your work is. But before I do that, how are you today?
I'm great, and it's good to see you. I like the difference in the time zones, like we are talking in the two sides of the planet. So it's exciting.
Yeah, I was thinking when we got started, we're on these two different sides of the planet, almost like two different hemispheres of the brain, but we're connecting and kind of moving our language through there. And,
Right.
as we're getting started here, you have been the inventor of some fascinating technologies. You've had a very fascinating career. You've won some awards, but I was wondering if you could maybe, in this introductory video, maybe give people a little bit of background about how you got started.
Yeah, well, I actually always was very interested in the brain. So I learned some physics, I learned some biology, some medical studies, and physics was really my main love. And when I started understanding in my PhD studies already the mode of action of antidepressant medications, this was my main interest was how really the brain works, and specifically how do psychiatric disorder mess our brains and how medications can fix it. So this was my main curiosity when I was much younger, like 25 years ago. Then I realized that we should use the physics of electromagnetic fields to change the brain. So this was something that really happened only later on, after I completed my PhD studies in Israel. I moved for a postdoctoral fellowship at NIH in the United States, and there I learned about electrical stimulation. And I was fascinated by the fact that I can implant electrodes to rats in the reward system, like the lateral hypothalamus or other parts of the brain that where the fibers of the reward pass through. And then rats would learn to press a lever in order to inject currents to their brain. And they will get crazy about it. They will not leave the lever. And I did have experience before with the rats, with animal behavior. And we can get rats to self-administer cocaine or other drugs, and it takes time to really teach them to do that, and they do become addicted. And then we can learn about the changes, the plasticity in their brain, and what goes wrong during the addiction process. But for electrical stimulation, it was so easy. I mean, they learned it so fast. It was so strongly, so rewarding. This was fascinating. So this was actually where I started thinking about we should use this electrical stimulation or electromagnetic stimulation using external coils in humans. We also tried it in rats to manipulate the electrical activity of the brain and make changes to brain circuitries. So this was a long answer to your short question, but yeah, I think really it started from pharmacology of antidepressant drugs and into the physics of electromagnetic fields to manipulate brain plasticity.
I've often seen a pattern with people who find themselves fascinated with neuroplasticity and behavior and drugs that elicit behavior to help addiction or depression or anxiety. And that's been a pattern of people being affected in their lives by that, or having someone close to them affected that. Was that the case for you?
Myself, not. Some others in my family, yes.
Mm-hmm.
Psychiatric disorders. And I was actually, I always was afraid during my adulthood. I mean, during my when I was a teenager, of becoming schizophrenic. I always thought that I'm on the border of being. I was afraid. I was anxious actually about it. That I might lose sanity, right? If I pronounce it right. So, but nothing happened to me. So I never experienced psychedelic drugs except for my research when I tried to study the mode of action of THC, and this was actually during my postdoctoral fellowship at the NIH. So I had a very pure, compound there to inject the rats and learn about get rats to self-administer THC directly to their brain. So they press the lever to get THC directly to the brain and find the trigger zone in the brain for the effects of tetrahydrocannabinol, so cannabis, right? So I thought that if I'm studying that, I should experience it myself. So this was the first time I experienced that. So I took this pure THC that I had from the lab and put it on a cigarette, and I smoked it and I felt nothing. I said, well, I went according to the literature to the average dose of THC in a joint, and it had I felt like it had no effect on me. And I thought, yes, also when I take alcohol, it doesn't really affect me. I need very high doses to get affected, so it's probably not affecting me. So I went into my car going home through the beltway of Baltimore. That was where I lived. And after maybe 20 minutes, I felt like, which exit should I go out? And I was driving there for 3 years, I was working at, and so then I started feeling the effect. But other than that, I had no real experience. Then I got the way home eventually, but no experience with that myself, except for my family. There were some issues in my family. But yeah, I think that my interest in the field did not come from from the family. It came from pure curiosity on how our brain works and where is the source of self, and the interaction between body and mind was always very interesting for me. When I read a book, I think I was like 16 years old when I read a book of an Israeli philosopher named Yeshayahu Leibovich, really talking about the conflict, the dualistic question about the interaction between brain and mind, and this actually started my interest in the field, not personal or family issues.
Thank you for sharing that story. It's it's so comical to be like, yeah, this one didn't really affect me. You get in your car and start driving, and
yeah.
I think a lot of people I think anyone who has tried a really large dose of cannabis, especially the first time, has had a story that's like, yeah, this is not working, but then it does work and stuff like that. It's interesting. If I move forward in the conversation, just for time's sake, when we think about neuroplasticity and whether it's transcranial magnetics or if it is, when you think about it, is it the brain bypassing parts of the other brain, like open heart surgery bypasses a blocked vein? Like, is that similar to how neuroplasticity works, or is it just new connections being made in different parts?
Okay, so now we are really going fast forward to the technology that I was together with my colleagues using electromagnetic fields with transcranial magnetic stimulation, and now to really explain this, first we should know that when you induce a single pulse, okay, just a single pulse, put it, let's say, on your motor cortex, like it's a strip between your two ears or so. So you put the coil over here, you come to my lab, I press the button, and your hand will jump even if you try to resist it, right? Because it stimulates the pathways that go from the decision to make the movement through your spinal cord all the way to the muscle, and the hand moves, and you cannot resist it, right? So this is a single pulse effect. But to your question, when we use TMS to change the brain or change circuitries in the brain to change behavior, or to affect diseases and so on. It's not a single pulse that can just make your hand move. We place the coil over the relevant areas of the brain. In the case of depression or addictions that we are trying to treat, we put it over the prefrontal cortex, different parts of the prefrontal cortex, and then we apply multiple pulses, many repetitive pulses, like 3,000 per day,
Wow.
in order to change the connectivity in the circuitry, to make a stable change, not just to induce a single, pulse that can make a functional change in your behavior, like make your hand or leg jump, but to really affect the connectivity in the circuitry. And we have even more advanced technologies we are now developing, that instead of just stimulating a certain area in the brain, we stimulate several areas and coordinate the timing between the stimulations in order to really change the circuitry in the brain that we believe is involved in the pathology of a certain disease. So the answer, again, it was a long answer to a short question. It's not that we are affecting a certain area. It's that we are affecting the connections between different areas in the brain by multiple sessions of such stimulation. And a single session, even these 3,000 pulses per day, cannot induce a lasting effect. If we want to really change the brain, the circuitry, we have to repeat that daily for several weeks, although we can get an effect after like 2 weeks, like 10 sessions or so of stimulation. But to really maintain the effect and have a therapeutic effect like in depressive patients, we need to maintain the treatment for several weeks. Yeah.
It's so, it blows my mind to think that like that potential methodology can have such, even if you do it over a few weeks, people are on drugs for their whole life. Like a few weeks pales in comparison to being on something that can change who you are for your life. Is it changing the structure of the brain? Are we seeing long elongated dendritic spines and like,
yeah.
is that kind of stuff happening?
Yes, so there is some evidence for that. Some changes in the dendritic tree. Some work in my lab where we tested this in animals and models, and we could learn about like creation of new neurons in the dentate gyrus of the hippocampus, or changes in the density of the dendritic tree. But the main thing that we believe is happening is actually in the receptor, in the molecular level. So you don't really change the structure of the brain. It's more that you change the strengths of the connectivity between neurons in the brain. So say we know that like in the human brain, we have 100 billion neurons, right? And when you apply stimulation, you can, with TMS, you can stimulate at once several millions of neurons. And the connectivity in the circuitry between these neurons can change and have a lasting neuroplasticity effect if you apply these pulses repeatedly and for several sessions over several weeks, or at least several days. Now, we do have some studies, recent studies, like that we performed in alcoholic patients, where we apply the stimulation for those who are seeking to, the people that are really addicted to alcohol and are trying to cure their addiction. And we were successful in several certain parameters that we applied. We tried different parameters until we found. So the parameters that were effective in treating alcohol addiction also induced some changes in the white matter in the brain. So question, we do also see in this case very specific areas in the brain where we could see changes, structural changes, indications for some mini structural changes following 3 weeks of treatment with 3,000 pulses per day over 3 weeks, like 15 sessions altogether, 5 days a week. And we compared the MRI before and after. And we did also some changes in white matter, connectivity patterns.
You mentioned MRI. Is that the way in which, is that one of the ways in which you're measuring the performance and the overall, efficacy, the effectiveness and the efficacy of this whole thing? Or is it some neurofeedback imaging as well? Or how do you measure and manage this process?
Yeah. So the main outcome measures are behavioral, right?
Okay.
We get behavior. In the case of addiction, we cannot just rely on the reports of the patients or the subjects of the study. We also take some urine or blood samples in order to see how much they drink before and after this treatment and so on. So we have some objective measures, but most of the outcome measures are questionnaires or cognitive tests or in front of a computer test, depending on the specific study we are talking about. But the main outcome measures are behavioral and cognitive performances and questionnaires. We do have MRI in order to understand the mechanism. So we look at functional MRI, measures resting state, activity, connectivity between areas that are helping us to understand how we change the brain. And we don't have enough information. We still don't really understand all the mechanisms, but these are the ways which we use to understand what we did to the brain. But our main outcome measures eventually are the clinical ones and the behavioral ones.
Yeah, I'm wondering, do you extend those questionnaires to like the patient's loved ones? It seems like sometimes the family member is a very good barometer of what's actually happening to someone else, just because they're an observer. Do the questionnaires go to the loved ones as well?
It should, but it's usually not the case. I mean, for one study we had, so we have to really detail about the different studies we had. We had studies in depression, we had studies in different types of addiction. The only case where we did have some input from family members was a study we did in ADHD and for children, and there we want to also hear about the parents' input. But in most studies, we only get the input from the patient itself and from the MRI, fMRI of that patient, or from EEG. We also use a lot of studies where we use electroencephalogram, EEG, to look at changes that we can measure over the treatment or predictors of response. We found, for example, in a recent study in depression, we tried 2 different coils affecting either the lateral or the medial prefrontal cortex. We compared the effectiveness of lateral versus medial prefrontal cortex stimulation to treat major depressive disorder in patients who did not respond to medications, patients that are resistant to medications. And we were looking for patterns of EEG that can predict which patients are going to respond to the lateral stimulation on the sides or to medial stimulation. So, and eventually this is a recent study we published. We did find some interesting patterns that indicate that some type of depression, also behaviorally, would respond better to the lateral stimulation, and other parts of depression would respond to the medial stimulation. And along with that, we also find some electroencephalogram, EEG patterns that are characterize the depressive type of patient that will respond to stimulation on the sides versus prefrontal cortex sides, lateral, and other types of depressive patients that will respond better to medial stimulation. That's our very hot study that was published recently, and I'm very proud of it, actually. In the field of addiction, actually, we didn't get to that level yet. But in depression, we already can predict the response based on some clinical and electrophysiological patterns that are specific for that patient, like personalized medicine using brain stimulation for depression.
That is fascinating. It kind of changes the landscape for depression when we start trying to understand where it's located. I know that doesn't thoroughly make sense, but when you figure out, okay, over on this side is this kind of depression, and I was just thinking, like, from what I've read, people that are right-handed seem to utilize the left-hand hemisphere. People that are left-handed use the right hemisphere. Do you have to take that into account for each sort of diagnosis and each sort of treatment, whether someone's left-handed or right-handed, or is there a diet involved in it? If they eat like green leafy foods, does that change the way their
Maybe.
metabolism and stuff is running?
Yeah, I maybe, but we didn't take this into account in our studies. In studies where we use TMS to study the motor cortex, the motor responses, we only take right-handed
Okay.
subjects, but some other labs did look at this more. But I'm sure that anything you do in life will affect the brain, and this can affect the outcomes of stimulation. But we can't really control all these parameters when we do the studies.
It's fascinating to me, and I know that, I hope the people listening to this or watching this understand that what we're going through right now is just kind of a little teaser of your work, so that for our next session we can do a deeper dive. And there's so much information in here, and we're moving through it because it's fascinating, and I think that the audience will really enjoy just kind of teasing people with a nice set of hors d'oeuvres to get people's palate wet for what we got coming up in the future. But is this recent study that you did that you're excited about, if you were to put on, or if you were to underscore 3 parts of this new study that you're really excited about, what would those 3 parts that you highlight be?
In this specific study or in all my career? Because I thought that you are more interested in 2 other studies that I did earlier. And so I'm not sure what you really mean, but I think that the studies that we did on smartphones and finding that, how people change when they are getting to use smartphones. And this was also using TMS, or my study on self-awareness, where we tried with brain stimulation to affect self-awareness. Studies that I think are more interesting to the wide public. But this study that is more practical is like optimizing our way to treat depressive patients that are really suffering and do not respond to medications. So this recent study where we characterize the specific patients and find out which type of stimulation or location of stimulation would be optimal, I'm very excited by this because it can really help people. But we have to really decide where to focus our conversation. Because I thought that you will be more. Based on the introduction and what I read about your interest earlier, you will be more interested to hear about the not just about clinical studies helping depressive patients or addicted or alcoholic patients, but more about the studies we did in healthy subjects and looking for how stimulation can affect self-awareness, or what changes in the human brain following smartphone use. And in this actually study, we also used TMS to try to probe changes in the brain that were induced following several months of using smartphones in those who originally used only stupid phones. And this study couldn't be done today, by the way. This study could only be done many years ago, before everyone had his own smartphone. So we were smart enough to identify the potential, and had students in my university that didn't yet have smartphones, but only stupid phones, and we gave them smartphones and followed the development of their brain. So we should next time maybe talk about studies as well.
Yeah. Do you see maybe in the future your company Brainwaves making a smartphone that's also a coil that actually helps people?
Yeah. Well, so far it's a nice idea, but so far we need big coils. A small smartphone will not do the job, because in order to induce an effective field from physical limitation, we need a large coils in order to reach deeper into the brain. This Brainsway company is actually taking advantage of the shape of the coil and the size of the coil in order to really reach the relevant brain regions. To reach deep enough into the brain, we need big coils. So a smartphone will not do it. A smartphone may control the software, but cannot replace the helmet, the coil that we put on our head. We need a big coil. And particularly these new developments that we're having, where we have in the helmet several coils in order to stimulate different brain regions, coordinate the timing of the stimulation in order to change connectivity in parts of the brain. Of course, this cannot be done by a miniature, device. It's a big helmet with many coils inside.
It's absolutely fascinating, and I am fascinated by all of your studies, and so it's hard for me to move through them all because I know we're on limited time, but I think we did a great job at getting people a little sampler platter of what our conversation is going to be at. I think we gave people enough to chew on where they can go into the show notes and start looking for themselves about some of the technologies that you've invented, some of the studies that your lab is doing, and some of the other great doctors that are at your lab and what they're doing. And maybe if there is a greater power at work, maybe we'll even inspire someone to begin moving in the next generation of thinking about this. And so I want to be mindful of your time. I know that we had a little snafu in the beginning, and I apologize for that, but I want people here to know we got more coming up. And before I let you go this time, though, where can people find you, and what do you got coming up?
Where can people find me? In my lab, usually most of the day, or at home. I'm most of the year I'm in Israel. I travel a lot to conferences, also abroad, mainly in the U.S. So when there are where there are conferences on brain stimulation, I'm there. Sometimes I provide lectures in these type of international symposiums and conferences. And but most of the year I'm in the lab, in my own lab in the Ben-Gurion University in Beersheba in Israel. But did you mean that, or maybe I missed?
Well, I was wondering if you had like your own website, or if like
where they can find me virtually.
Yeah. I didn't mean to. I'm sorry about that. Like that kind of came out weird on my part. I apologize.
Yeah, no, it's my English. Well, they can find me. I'm not too much in the way on like I'm not very active in social networks. I'm too busy with my But we have a website for the lab. We don't update it very often, but yes, there is a lab, a website for the Zangen lab, for my lab. You can find it in the Ben-Gurion University, where my lab is. And you can also find a lot of information in Brainsway. Brainsway is a company that was actually founded based on the patents that I've developed together with my colleagues at the NIH. And they just licensed the patents from the NIH. So Brainsway, and I'm serving as a scientific consultant for Brainsway, and I'm one of the founders of the company. So although I'm full-time professor in university, I interact a lot with Brainsway, and Brainsway actually is doing a much better job on the web, like because it's commercial, it's a public company, it's traded in the Nasdaq and Israeli stock exchange. So this website of Brainsway will also have a lot of information about brain stimulation using the deep TMS. This is actually the technology that we've developed, the deep transcranial magnetic stimulation, these big coils that allow stimulation of deep brain regions in order to treat psychiatric and neurological disorders. So this website of Brainsway actually has a lot of interesting information and some testimonies from many patients who already benefited from the treatments. These treatments are already approved by the FDA, and there are more than 150,000 patients that were already treated with these devices, and it's also covered by insurance. So of course there are many testimonies, and Brainsway's website is full with them. So anyone who really wants to learn about deep TMS and its potential in psychiatry can see much also in the Brainswave website. If you're more interested in the scientific, specific studies that we're doing now and the future of the field, there is some in the Brainswave site, but that you will find more in my own website, which is not very much updated. But still, you can find much in the Zangen Lab website as well.
Yeah,
So
I would
find me virtually in these places and physically, either in my lab or at home, or when I come to, conferences in Europe or in the US in the field of brain simulation. Yeah.
And I would recommend that everybody check out the Brainswave site and also Google Scholar if you want to read some individual reports of what you got going on. And I'll put those links in the show notes so everybody can check them out. And I'm really thankful to talk to you. I know your time is important, and I'm thankful for the things that you're doing. I think it's helping people around the world. And if we're being honest with ourselves, everybody knows somebody who's had problems in their life that can probably benefit from new technologies and better understanding of how the brain works. And so I'm really thrilled to get the opportunity to help share some information and to get you looking in the eyes. And I just want to say thank you. So I appreciate it.
And I would like to thank you as well, because I looked at your website, really, and you have very, very innovative, fascinating type of interview. I really like it. And thank you for giving me the opportunity to be part of your show. I'm really thankful for that. Really, it's a very unique way of delivering, information to people in very interesting area of I think the area that you're interested in mental health and how the brain works is something that everyone is interested. You don't need to be a neuroscientist to really be interested in it, and you are providing this in a very accessible way. So I'm sorry for my limited vocabulary in English, but I hope I was able to explain what I mean, right? I think that many people are interested in the interaction between mind and body. You don't need to be a professor in university to be interested in it. Everyone is interested in it, and it looks like you are really into this question, and your interviews, your different the audience that you're looking at, and the people that you invite for your interviews are really trying to touch these interesting questions.
I really appreciate the kind words, and that's exactly what I'm trying to do. I'm hopeful that I can provide a view from different areas, and maybe one person's view helps out this person, but if you put all those views together, it's like you can begin to get a bigger image of it. And I'm fascinated by the way we think. I'm fascinated by mental wellness and mental illness, and I've had plenty of people in my family that were affected by it. And your English is a million times better than my Hebrew, because I don't speak it one bit at all. So I'm
happy I was able to interview you also a little bit and let you speak about your initiative.
Yeah. And this is I gotta let you go. Your wife is gonna be upset with you if I don't let you go right now. And so thank you so much for your time. And ladies and gentlemen, this is just the first one. We're gonna go much deeper. So thank you to everybody for your time. Doctor, I really appreciate your time, and I'll be reaching out to you here shortly to set up some more conversations. I really appreciate your time, and I hope you have a phenomenal day. All right.
Bye-bye.
Okay, aloha.